The origins of organic chemistry. The modern definition of organic chemistry is the chemistry of carbon compounds. What is so special about carbon that a whole branch of chemistry is devoted to its compounds? Unlike most other elements, carbon forms strong bonds to other carbon atoms and to a wide variety of other elements. Chains and rings of carbon atoms can be built up to form an endless variety of molecules. This diversity of carbon compounds provides the basis for life on Earth. Living creatures are composed largely of complex organic compounds that serve structural, chemical, or genetic functions. The term organic literally means derived from living organisms. Originally, the science of organic chemistry was the study of compounds extracted from living organisms and their natural products. Compounds such as sugar, urea, starch, waxes, and plant oils were considered organic, and people accepted vitalism, the belief that natural products needed a vital force to create them. Organic chemistry, then, was the study of compounds having the vital force. Inorganic chemistry was the study of gases, rocks, and minerals, and the compounds that could be made from them. In the 19th century, experiments showed that organic compounds could be synthesized from inorganic compounds. In 1828, the German chemist Friedrich Wöhler converted ammonium cyanate, made from ammonia and cyanic acid, to urea, simply by heating it in the absence of oxygen. Urea had always come from living organisms and was presumed to contain the vital force. Yet ammonium cyanate is inorganic and thus lacks the vital force. Some chemists claimed that a trace of vital force from Wöhler's hands must have contaminated the reaction, but most recognized the possibility of synthesizing organic compounds from inorganics. Many other syntheses were carried out, and the vital force theory was eventually discarded. Because vitalism was disproved in the early 19th century, you'd think it would be extinct by now, and you'd be wrong. Vitalism lives on today in the minds of those who believe that natural, plant-derived vitamins, flavor compounds, etc., are somehow different and more healthful than the identical artificial synthesized compounds. As chemists, we know that plant-derived compounds and the synthesized compounds are identical. Assuming they are pure, the only way to tell them apart is through 14-carbon dating. Compounds synthesized from petrochemicals have a lower content of radioactive 14-carbon and appear old because their 14-carbon has decayed over time. Plant-derived compounds are recently synthesized from CO2 in the air. They have a higher content of radioactive 14-carbon. Some large chemical suppliers provide isotope ratio analysis to show that their naturals have high 14-carbon content and are plant-derived. Such a sophisticated analysis lends a high-tech flavor to this 21st century form of vitalism. Even though organic compounds do not need a vital force, they are still distinguished from inorganic compounds. The distinctive feature of organic compounds is that they all contain one or more carbon atoms. Still, not all carbon compounds are organic. Substances such as diamond, graphite, carbon dioxide, ammonium cyanate, and sodium carbonate are derived from minerals and have typical inorganic properties. Most of the millions of carbon compounds are classified as organic, however. We humans are composed largely of organic molecules, and we are nourished by the organic compounds in our food. The proteins in our skin, the lipids in our cell membranes, the glycogen in our livers, and the DNA in the nuclei of our cells are all organic compounds. Our bodies are also regulated and defended by complex organic compounds. Chemists have learned to synthesize or simulate many of these complex molecules. The synthetic products serve as drugs, medicines, plastics, pesticides, paints, and fibers. Many of the most important advances in medicine are actually advances in organic chemistry. New synthetic drugs are developed to combat disease, and new polymers are molded to replace failing organs. Organic chemistry has gone full circle. It began as the study of compounds derived from organs, and now it gives us the drugs and materials we need to save or replace those organs.